Hello, welcome to the chapter on conic sections. We're going to be looking at parabolas today. A conic section is when a plane intersects a cone or a double napped cone to create one of these shapes you see at the bottom here. We will specifically be looking at parabolas today, which is something that we've already looked at. We've seen parabolas with the equation in vertex form. We've also seen parabolas with the equation in standard form as well. Today we're going to look at the definition of a parabola and create a new equation that we'll work with in this section. So let's look at the definition. It says a parabola is the set of all points in a plane that are equidistant from a fixed line, the directrix, and a fixed point, the focus, that is not on the line. So a parabola has a line in back of it called a directrix and a point in the cup of the parabola called the focus. And what the definition says here is that if you go from the focus to any point on the parabola, and then from that point on the parabola you go to the directrix and you do create a 90-degree angle there, then these two line segments from the directrix to the parabola and from the parabola to the focus, these two line segments are equal to each other. So you could go to any point on the parabola. If I decided to go here from the focus and then directly to the directrix, then once again these two line segments would be equal to each other. So the way to come up with this new equation that we're going to be working with today is pretty easy. If you place the parabola on the xy system with the vertex at the origin, we create two distances that are equal to each other from the directrix to the parabola and from the focus to the parabola. These two distances are equal to each other, and we can use the distance formula to come up with this new equation we have here at the very bottom. So we have a new equation that has this variable p in it, and p will tell us many things about the parabola. It tells us how wide the parabola is. It tells us the distance from the vertex to the focus, the distance from the vertex to the directrix. That's the p value. Let's go to the next page here. We're going to look at parabolas on their side and parabolas up and down. So on the left here, we have a parabola on its side, and when we're working with a parabola that is on its side, we're going to be dealing with y squared. When we're dealing with a parabola that is either faced up or down, then we're dealing with the x squared. Okay. A couple other things. If the p value is positive, then the parabola is going to face towards the positive x direction. Also, if the p value is positive, it will face towards the positive y direction. If the p-value is negative, however, the parabola will face towards the negative x direction. And if it's a parabola that is with the x squared, then you're going to see a parabola that faces towards the negative y direction if the p-value is negative. So once again, the p-value tells us the distance from the vertex to the focus, from the vertex to the directrix. It also tells us the focal width of the parabola. The focal width is literally the distance from one end of the parabola to the other end of the parabola, a line segment that goes through the focus point. This is known as the focal width. So focal width goes through the focus from one end of the parabola to the other end of the parabola. It's the line segment that goes through the focus. And this is found by taking the absolute value of 4 times p. So let's go ahead and start working with parabolas that are centered at the origin. For this particular problem here, y squared equals negative 8x. We want to find the vertex focus, the focal width, and the directrix, and then graph. So, excuse me. First of all, the vertex, that's really easy. The vertex for this type of parabola is at 0, 0. And we want to figure out what the focus and the focal width and the directrix are. In order to do that, we need to figure out what the p-value is equal to. And so what I want to do to figure out the p-value, I want to set this equation, I want to compare this equation that was given to the general form of the equation of a parabola that's on its side. So we have y squared equals 4px. And so right now, I want to figure out the p-value by comparing these two equations. I see that I have a negative 8 in front of the x, and I have, for the general form of a parabola on its side, the 4p next to the x. So to find out the p-value, simply need to take negative 8 and set it equal to 4p, and then solve for p. So that tells me that p then is equal to negative 2. So I have a negative p-value, and because I'm dealing with y squared, that tells me that I'm going to have a parabola that's on its side faced towards the negative x direction. Okay, so let's go ahead and figure out the focus and the focal width and the directrix. I know that because I have a p-value of negative 2, I'm going to go 2 spaces to the left here to find the focus point. The focus point is at negative 2, 0. Remember that the focus is in the cup of the parabola each time. The directrix is the line in back of the vertex here. And so the directrix is this line where x is equal to positive 2. Alright, the focal width, remember, is the distance from one end of the parabola to the other end of the parabola that goes through the focus. So to find that focal width, we need to take the absolute value of 4 times p, and that gives us the focal width. So it's going to give us a negative 8, and then we take the absolute value to get a positive 8. And what that means literally is that this distance, this green line segment's distance, is equal to 8. You go up 4 top, down 4 bottom, and we get a distance of 8. Excuse me. And here I have all of my answers. Okay, let's move to the next problem. We want to find the parabolic equation with a directrix of y equals 2 and a focus of 0, negative 2. I think the easiest thing to do is to graph these, the directrix and the focus, and then try and understand the type of parabola that we're looking at, and then try and come up with the p-value. So I have a directrix at y equals 2. So that means I have this line, this horizontal line here, and this is the directrix, and I have a focus when x is 0 and y is negative 2. So here's our focus point here. And this visual gives me a pretty good understanding of what my parabola is going to do. Remember that the focus is within the cup of the parabola. So my parabola is going to be face down here. The directrix is in back of the vertex of the parabola. So because I have a parabola that's face down, I know I'm dealing with the equation x squared. I have x squared equals 4py that I'm dealing with. The only thing that I need to find to come up with the equation of this parabola is the p-value. What is the p-value? The p-value is going to be negative because we're faced towards the negative y direction. Remember, the p-value is the distance from the vertex to the focus point, and we see that we have a distance of 2 there. So because we're face down, p is going to be equal to a -2. And we simply need to plug in that p-value of -2 to come up with the equation of the parabola. We have x squared equals 4 times -2 times y, and that gives us x squared equals -8y. And that's it. That's the equation of our parabola. So we'll also be looking at parabolas with vertex other than 0, 0. Vertex with h and k. And you might recall that we used hk with a parabola in vertex form. The equations, the way they've changed is we add or subtract an hk value directly on the x and the y value from the previous equations. If you want to identify the vertex of a parabola just by looking at the equation, you take the opposites of the h and the k to come up with the vertex. So if your equation has a y squared, you're going to have a parabola that's on its side. It's going to have a horizontal axis of symmetry. If you're looking at an equation where you have an x squared, your parabola is going to be faced up or down, and it will have a vertical axis of symmetry. Here we have the focus and the directrix. We have really a formulaic way of finding the focus and the directrix. To find the focus, you need to have the vertex and the p-value. To find the directrix, you're going to need to know the vertex and the p-value as well. And like I said, these are the formulaic ways of finding those the focus and directrix. I personally find it's best to find the focus and the directrix by graphing the given information and trying to come up with the focus and directrix. Also, the p-value once again tells us whether the parabola is faced up or down or left or right. Let's go ahead and get started by working on a problem here. We have a directrix at y equals 7, and we have a focus at 2, 1. So I have the directrix drawn, I have the focus drawn, and this visual really helps me have a better understanding of what I'm looking at. I know that I'm going to have a parabola that's going to be faced downward, because remember that the focus is within the cup of the parabola, and the directrix is in back of the vertex. So because I have a parabola that's faced downward, I'm dealing with the x squared equation. So I have the x minus h power 2 is equal to 4p times y minus k. And to come up with the equation of this particular parabola, I need the hk, I need the vertex of the parabola, and I need the p-value. So the vertex of the parabola is right in the middle of the focus and the directrix. So I know that the distance from 7 to 1 is 6. So to find the vertex, I simply need to go up 3 from the focus point. So this is right where my vertex is located. And that means that I have a vertex at 2, 4. The p-value is the distance from the vertex to the focus, or from the vertex to the directrix. We have a distance of 3 from the vertex to the focus. Because our parabola is face down, p is equal to -3. So let's go ahead and plug everything in that we have, and then we'll have the equation of the parabola. Plugged everything in, simplified a bit, and here we have the equation of our parabola. Let's go ahead and look at the next problem here. We want to find the vertex, focus, directrix, and then graph. So I see I have a y squared, and that tells me I'm going to have a parabola on its side. In order to find the focus and the directrix, I need the p-value. And so I need to compare this equation to the general form of a parabola. So let's start making that comparison. In order to make the comparison, first I need to factor out -6. So let's go ahead and do that. So I factored out the -6, and I've written the general form of a parabola on its side right below the equation that we have, so I can make a comparison between the two. I see that my vertex is going to be positive 2, -5. Remember, we take the opposite values there. And the p-value, I'm going to use that to come up with the focus and the directrix. So I need to make the comparison between -6 and 4p. So we have a p-value of -3/2, -1.5. That tells me that our parabola is going to be on its side faced to the left because we have a negative p-value. Let's go ahead and graph what the parabola should look like, just a generalized graph of what's going on so far, and that visual will help us understand the placement of the focus and the directrix. Okay, so we have a parabola on its side faced to the left, and I've drawn this based off of a negative p-value in the vertex, knowing that the parabola is on its side as well. We know that the focus is going to be within the cup of the parabola, and the directrix is going to be in back of the vertex there. We just have to identify what the point of the focus is and the line of the directrix is. Let's go ahead and deal with the focus first. To find the focus, we need to have the vertex. We have that. And we can see here that the focus changes the x value of the vertex. The y value is the same. So what I've done here is I've rewritten the vertex, and I've added on the p value onto the x value of the vertex to come up with the focus point. So we just need to find a common denominator and add up in order to find the focus. So we have a focus right at x is 1/2, y is -5. And looks like I'm going to have to move that point over to the left just a little bit. Okay, so the directrix is found by taking the x value of the vertex and subtracting the p-value. So let's go ahead and figure out the directrix. We need a common denominator. We got to go 2 minus 3/2. So that's the same thing as saying 2 plus 3/2. Alright, so we've come up with 7/2 as our directrix, which is 3.5. So we see that we go right in between 3 and 4 to get 3.5 there. And that's all we need. Let's move on to the next problem. We want to find the equation of an upward facing parabola with the vertex at -1, 3 and a point on the parabola at 3, 5. Okay, we have an upward facing parabola, so we're going to be using this equation here. We have a point, we have a vertex. Remember that all we need to come up with the equation of the parabola is the hk along with the p-value. And we have hk, we don't have the p. But we do have a point on the line, which means that, not on the line, on the parabola, which means that we can plug everything in and solve for p. Okay, so I plugged everything in and I can solve for p here. Please note that, remember, we take the opposite of the hk values when we plug them into the actual equation. Let's go ahead and use our algebra skills to solve for p. Okay, so we have p. And we have hk, which means that we can come up with the equation of the parabola pretty easily. Okay, so we plugged in, and here's the equation of our parabola. Let's move on to the next question. We want to prove that this is the graph, this is the equation of a parabola, and then we want to find the vertex, focus, and the directrix. What that means we need to do is complete the square with this equation. Remember that when we complete the square, we have to, we can't have a coefficient other than 1 with our coefficient right next to, in this case, the x squared. What I want to do is I want to isolate the x's to one side and then pull everything else to the other side so that we can complete the square. Let's go ahead and write that out. Okay, so I've isolated the x terms to one side and pulled everything else to the right, and I need to complete the square. And like I said just now, I can't have a coefficient other than 1 with the coefficient right next to the x squared, so I need to divide everything by a 3. And this gives a situation where we can complete the square. We look at the value, we look at the number right next to the x, the -2, take half of it, raise it to the power 2, so half of -2 is -1 to the power 2 is 1. We have to add that to both sides. And what that does for us is that gives us, on the left, a perfect square trinomial. And on the right, we have to factor out a 2 in order to put this in the form of the equation of a parabola. So let's factor out the 2. Okay, so I've put this equation in the form of a parabola, and this gives us the ability to identify the vertex, the p-value, which will enable us to find the focus and the directrix. You might be a little curious how I factored out that 2 there. It might have been a little bit confusing to you. But essentially what I do is this. I think 2 times what is going to give me a 1 there? Well, 2 times 1/2 is going to give me a 1. You know, solve for the unknown gives you a 1/2 there. So hopefully that helps you out if you were struggling with that piece. Let's go ahead and plot the vertex and see what the graph should look like. Okay, so we have a parabola with the vertex at 1, -1/2, and it's faced up. The p-value is positive, so it's faced up. So we know that the focus point needs to be somewhere in the cup of the parabola, and the directrix needs to be in back there. So that visual will really help us understand the placement of the focus and the directrix. Let's go ahead and find the p-value. Okay, so p is equal to 1/2, and that means that I'm going to have to add 1/2 onto the y value of the vertex to come up with the focus, and I'm going to have to subtract 1/2 onto the y value of the vertex to come up with the directrix. Okay, so there is our focus point. Let's go ahead and find out what the directrix is equal to now. Okay, so we have a directrix at -1, y equals -1, and last thing I want to write out is the vertex, even though we know what it is. The question is asking for it, so let's go ahead and write it out. We have a 1, -1/2. Okay, let's move on to the last question here. Let's end this lecture by talking about some applications of parabolas. The main applications of parabolas involve their use as reflectors of sound, light, radio waves, and other electromagnetic waves. If we rotate a parabola in a three-dimensional space about its axis, the parabola sweeps out a paraboloid of revolution. If we place a single source at the focus of a reflective paraboloid, the signal reflects off the surface in lines parallel to the axis of symmetry. This property is used by flashlights, headlights, searchlights, microwave relays, and satellite uplinks. The principle works for signals traveling in reverse direction as well as signals arriving parallel to a parabolic reflector's axis are directed towards the reflector's focus. The property is used to intensify signals picked up by radio telescopes and television satellite dishes, to focus arriving light in reflecting telescopes, to concentrate heat in solar ovens, and to magnify sound for sideline microphones at football games. So we're going to end this by working on an example that deals with this paraboloid of revolution. We have the reflector of a television satellite dish is a paraboloid of revolution with diameter 5 feet and depth 2 feet. How far from the vertex should the receiving antenna be placed? We want to place that receiving antenna at the focus point. And so we have to figure out the p-value based on these dimensions to figure out where to place the focus. Let's go ahead and draw what our parabola looks like in the XY system with these given dimensions. So this is the illustration of a paraboloid of revolution with a diameter of 5 feet and a depth of 2 feet placed within the XY system with the vertex at 0, 0. This type of parabola is represented by this equation when we have x squared equals 4py. And so what we need to do here is we have to figure out our p-value. That's going to tell us what where to place the focus. We could solve for p if we have an xy point. So let's go ahead and identify an xy point that is on this parabola. So we have two points here, and we want to figure out the p-value. So let's go ahead and plug in the point. We're going to plug in that point into the x and the y value, and then we're going to solve for p. Okay, so we plugged in a point, solved for p, and that gives us the distance of from the vertex that we need to place the focus. So we're going to place that focus about right here, and that represents 0.78125 feet. All right, I will be seeing you in class. Bye.